In this video, we'll learn how to use parametric substitutions for differentiation. Let's do that with a problem. X to the power 2 by 3 plus y to the power 2 by 3 equals to a to the power 2 by 3. We have these fractional powers for x, y and a, and we need to find dy by dx. Now there are many ways to solve this, but parametric substitution, as the name suggests, involves replacing x and y with some other function with some other parameter. But the challenge here is to figure out what those parameters are. How are x and y related to that parameter? That's the main challenge for problems like these. But the good thing is there are clues given in this equation. We can use those clues and some knowledge of trigonometry to get the right substitutions. Now pause the video, try this on your own first. Okay, let's do this together. The first clue that's given here is that squares are being added. If you look at it, it's a fractional power 2 by 3. But if you look at it from a different view, this is x to the power 1 by 3 squared. So this is a square. This is also a square and this is also a square. These are squares of 1/3 powers of x, y and a. And whenever squares are being added, think trigonometric functions. It's a very powerful clue. Next, we have cube roots. We are also involving the power 1 by 3. And whenever we have these fractional powers, think exponents. Probably, highly likely, some trigonometric function is raised to some power to get the values of x and y. Now, if you want a neat value of x or y, what should we replace x and y with? Here's the solution. If you replace x with a cos cube theta and y with a sine cube theta, let's see what we get. We have a cube, we have trigonometric functions. Let's see if we put x as a cos cube theta and y as a sine cube theta in this equation, what do we get? We have a cos cube theta to the power 2 by 3 plus a sine cube theta to the power 2 by 3. That should be equal to a to the power 2 by 3. If it's not equal to this, the substitution will not work. Let's look at this term first. This is a to the power 2 by 3 times cos cube theta to the power 2 by 3. So 1 by 3 times 3 is 1. This is written as cos square theta. Similarly, here we have a to the power 2 by 3 times sine square theta. This is exactly what we need, cos square theta and sine square theta. So this term, this left hand side, this becomes a to the power 2 by 3 times cos square theta from here and sine square theta from here. And both of them add up and they give us 1. So this becomes a to the power 2 by 3, which matches our right hand side, which means this substitution works. Not only it works because this term is equal to this term, it works because we can easily differentiate a cos cube theta and a sine cube theta with respect to theta. And this is the next part of this problem. We can differentiate x and y with respect to this parameter theta. We can find dx by d theta and we can find dy by d theta. So let's do that. So dx by d theta is a constant. Cos cube theta, here we can apply chain rule. We have 3 cos square theta times, now differentiating cos theta, this becomes minus sine theta. So differentiation of this is 3a or minus 3a cos square theta sine theta. What's the differentiation here? We have a times 3 sine square theta, again applying chain rule, times differentiation of sine theta, that's cos theta. So this becomes 3a sine square theta cos theta. And now comes the most important part where we have to find dy by dx. We're not interested in dx by d theta or dy by d theta. We'll use these as raw materials to find dy by dx. So dy by dx will be the ratio of dy by d theta and dx by d theta. So we'll divide this by this to get dy by dx. So this becomes 3a sine square theta cos theta divided by minus 3a cos square theta sine theta. Let's cancel a few things. 3 cancels out, a cancels out. We have sine theta and cos theta cancelling out. We have a negative sign and sine theta in the numerator and cos theta in the denominator. So that's minus tan theta. That's our answer. The differentiation dy by dx, that's minus tan theta. But wait a minute. Theta is not something that's present in the question. So to finish off the solution, we have to remove this theta and bring back x, y and a. So let's do that. let's figure out the value of tan theta. How do we do that? We can divide sine theta by cos theta. Either we can figure out the values of sine theta and cos theta separately and then divide them, or we can just divide these two equations. We have x upon y equals to a cos cube theta by a sine cube theta. A cancels out. Sine cube theta by cos cube theta will be tan cube theta. That's going to be y by x, the reciprocal of both the sides. So tan theta will be cube root of y by x. And this is what we can report. So our final answer dy by dx, that's equal to minus cube root of y by x.